that's fine, because at that point, these training wheels will be off. All right, so we now have conditions. We now have Boolean expressions. And again, a Boolean expression, to be clear, is just something in parentheses that evaluates or is true or false, 1 or 0. But there's a few other features here, among them called switches. So it turns out if you have a bunch of conditions, you don't have to say if, else if, else if, else if, else if, else. Just know that there's this other construct, this other piece of syntax altogether called switch, where all you need to do is actually enumerate cases one at a time. And we won't dive into detail on this one, but the takeaway here is that just as in Scratch, there's rarely, if ever, going to be one right or even one correct way of doing something. Rather, there can be any number of ways. And so also as a matter of style, when you start to have if, else if, else if, else if, else if, else if, that's just a lot of redundant words. So switch is just another way, as we'll eventually see, that you can simplify syntax by just listing them case by case by case. But the most powerful thing that we'll need ultimately are loops, because otherwise our programs can only do one thing and once, and that's it. So with loops, recall from Wednesday, we translated some sample Scratch blocks into the corresponding looping constructs. Now this is one of the scariest ones to look at first, but it's actually quite easy to use. In a for loop, you declare a variable, you generally called I by habit. Then you say how many times do you want to increment I, plus, 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 at which point you want to stop. And inside of this loop, you'll do something. So we can actually do something a little silly. Let me go over to gedit here. I'm going to go ahead and just create a new file. I'm going to call this on my desktop, let's say loop.c. And again, I'm just going to bang out some familiar lines. So include standard io.h. I'm not even going to use the CS50 library. Int main void. Now I'm going to do printf. How about this? So let's do, how about int n gets int. OK, I just lied, so I need the CS50 library. So no problem. So cs50.h, bug solved. So I'm getting an int from the user. And now what do I want to actually do? Well, I want to loop like this. For int I gets 0. So give me an int, call it I, initialize it to 0. Go ahead and keep doing this so long as I is less than n. And then keep incrementing I on every iteration of this loop. So Scratch kind of automated some of this for us. If you use the block like change variable by 1. It's a little simpler. But now let me do this. Let me indent here. And just as with if you're just executing one thing, I don't need curly braces around the for loop. Let me go ahead and print out the decimal number followed by a new line that's currently inside I. So very simple program. Ask the user for an int, print it out, then increment it, increment it, increment it, increment it. So let's see what happens. This is called loop.c. Let me go ahead and type make. It's on my desktop. Let me do make loop. OK, that's good. No errors. And let me go ahead now and run loop. OK, I need to type in a number, 99. OK, that's a pretty fast program, right? I can now scroll way back here. Now, of course, you can do some perhaps silly things. What might be a bug now in this program? Yeah, what if I'm kind of a difficult user and I say, how about -1? See what happens. What happened? It's already less than n. It's already less than -1. So what if I kind of goof and do something like this, right? This is a reasonable bug. Let me recompile and do make loop. And now let me go ahead and run loop. And now if I type something like 1, OK, that works. -1. Uh-oh. So now we sort of get to empirically test what the capacity is of an int. And just to think back to Wednesday, what is the largest int that we can actually represent? Yeah, so it's like 2 billion, give or take. It's 4 billion total if you have 32 bits. But if you want to use some negative, some positive, you actually have to sacrifice half. So it's roughly -2 billion to +2 billion. Frankly, this is going to take all day if we keep counting up this way. So let's actually do something a little fancier. In my program, rather than increment 1, let me go ahead and say multiply by 2. So this is just fancy syntax that we'll come back to over time. But this is just shorthand notation for saying, actually, let me do it more simply. I, on each iteration, is going to get the value of I times 2. So keep doubling it, doubling it, doubling it. That should get us out of here quicker. So let's try this. Make loop. Let me go ahead now and run loop. -1. What happened? Let's scroll back up here. What's going on? Yeah, so I'm kind of an idiot, right? I shouldn't start counting at 0 and then multiply by 2 an infinite number of times. That was not intended. So let's go ahead and do make loop, rerun loop with -1. Interesting. It stopped. It didn't keep going. It should have kept going, right? It should have kept going again and again, because so long as I is greater than n, just go on up to infinity. So what might have happened? Yeah?
It went past the highest number it could display.
Yeah, it went past the highest number it can display, and more specifically,
It became a negative number because it overflowed.
it became negative. So here's the curious thing. Just as with our example with humans, we had 8 bits. Just because I want to count beyond that 8th bit, it doesn't mean you get a free bit all of a sudden and now you have 9 bits and 10 bits, right? You are limited in capacity. So if we made all of these humans raise their hand and then we said, OK, add one more number to your total value, what would they do reasonably? Maybe one of them puts their hand down. Maybe all of them puts their hands down. In other words, if you keep changing zeros to ones again and again and you run out of permutations, you're going to have to start over. But unfortunately, once you start over and quote unquote overflow, well, what comes after roughly 2 billion when you overflow? How do you start over? It becomes -2 billion. So even though we didn't see it on the screen here, what happened is the zeros and ones changed into some pattern whereby it actually was representing a negative number, because again, we only have finitely many zeros and ones in 32 bits or even 64 bits. And so now we had the illusion of some negative number, and this badness happened. It just stopped. But a for loop is not the only option. We can actually use something called a while loop. And this shouldn't be too scary, too, because even in Scratch, you had repeat blocks, you had forever blocks, same idea, and we'll see different syntax. And then there's also this one, too, a do while loop, whereby it does something one time and then again and again and again. And so you'll see in problem set 1 in particular what something like this can do. Now let me just go back to the terminal window here and demonstrate just 2 things to pique curiosity as to what lies ahead. If I go into the prefabbed code here, you'll see a couple of things, one of which is called Thad Gavin, named after the guy. So this is when you really want to be anal and pretty print your code. You can actually make it look pretty by formatting it in this way. This is not what we mean when we say good style. This is a submission for a special contest where you try to outdo all of the other geeks. But what you can do here, which is pretty cool, is if we run Thad's program, you can do some crazy things just using these loops. So this is a C program. It was only a few dozen lines of code. You saw the whole thing. But with loops and with C, we can do things like this. And this is just the beginning. So with that said, let's call it a day. P set 1 will be posted tonight, and we'll see you on Monday.